I will introduce John Horel with the University of Utah, who is going to be speaking on monitoring weather and evaporation near the Great Salt Lake. And take it away.
All right. Hey, thanks very much. I really appreciate being here. And following Ben is a hard act to follow. And so where he's looking really big picture, I'm going to take you down a little bit into the weeds as far as some of the issues associated with water within the Great Salt Lake. And in addition to Colin, I have this acknowledgement of there's been a lot of other people that have been involved in the types of things that I'll be talking about today. So this is kind of a story. It has a timeline which is a little longer than Ben's, as I'll show here in a minute. But one of the things was that we started installing weather stations near and around the Great Salt Lake back in the late 90s. And Locomotive Springs, which is the station here on the left, it was installed, and when we put it in, the lake was about 15 feet from this station, and you can't see the lake from there. And I'll talk about it. And Fremont Island now is state-owned property and really a very useful site on top of the crest line there, and I'll talk quite a bit about HAT here in a minute. So the state has developed this Great Salt Lake Integrated Plan, which really does do an excellent job of sort of laying out current status and then also the future. But when it has weather in it, let's see if I can, which one is so you can see the precipitation here falling on the mountains, which is the way most people think about the issue. And then after that, the runoff and all the resources and everything that's used. And it has the consumptive use of water on the lake as well. But there's two things that are missing from here, and that is the precipitation falling directly on the lake, because that's a major part of the water balance. And then also the evaporation from the lake, and Ben talked about that as well. So when we think about water resources for the lake, you have to worry about, well, how much is actually falling on the lake itself, then the stream flows and the groundwater. And when you're talking about water losses, you're talking about the evaporation from the lake and all the upstream demands, and then also demands on the lake itself. So if you go back in time, if you looked at things at when the lake was really high and was concerned about, how is that going to move forward, the picture was kind of static. It was assumed that, what comes in goes out. And so when we look at the sources of precipitation, it boils down to, from a lot of this period was based on a mixture of high water and low water periods. And again, these kind of numbers roll around where the surface streams are 2/3 and the precipitation falling on the lake is 1/3 and groundwater. And then this kind of number as far as how much evaporation is falling from the lake. So starting in the 2000s, Dave Tarberton and his group really did a number of sensitivity studies, and there's been a lot of hydrologic modeling since then, and Ben touched on some of those. But this is a really important point that the fluctuation in the stream flow is really the dominant factor. And so as stream flow has diminished, that has impacted the level of the lake. But also the fluctuations in just the lake area affect how much water is directly falling on the lake and how much evaporation is going as well. So the work plan for this integrated plan touched on things such as, recognizing uncertainties in the amount of the evaporation, and then some of the unique characteristics of the water and land, the playa surfaces. And I missed Kevin's presentation yesterday, but I'm sure you for those that were here, got a good explanation as far as some of the issues related to dust. And then the really important thing is, how can we use observations, as far as my role, to try to reduce these uncertainties for ongoing hydrologic modeling that's being done in the research community, in the state, and so forth. Okay, so here's the simplified version with simple concepts, and that is we're dealing with a situation where if you look at it as what is the relative roles, one thing is just assume for the moment that stream flow in groundwater is controlled. So given the way things are right now, we have a lot more evaporation on the lake than we have precipitation, all right? And so how do these factors change? Well, the precipitation is, the things that are going to cause this to go down on the left side are if the lake surface area shrinks, then there's less water falling on the lake. We don't see really super large trends in total precipitation, but there are more dry years than wet years of late. And then any water that's really going to fall on the soil is going to, not really be available to the lake in most situations. So how do we gain water? Well, you obviously, if the lake surface area increases, then we're going to have more precipitation directly falling on it. And it's also really important that we know temperatures are increasing, quite significantly in the Intermountain region. And that can lead to more intense summertime precipitation, and I'll show some examples of how that impacts, so even if on the net you may not have a whole lot of precipitation over the region, you can still have very localized heavy precipitation. So let's look at it at the other side. Well, you could swing this balance up if you have less surface area. It's going to reduce the amount of evaporation. And then also, if the salinity goes up, then you're going to have less evaporation. The rate at which the evaporation happens is going to be less. So, of course, what's going to drive this further down is actually more lake surface area, because now you spread the water out further and it's going to be in shallow areas where the evaporation is relatively large. And if the lake gets warmer and the air temperature over the lake gets warmer. So all these things are competing factors that have to be used in models of the hydrologic cycle in order to test these out. Because it isn't a simple one, that reducing or increasing the lake area is going to give you a single kind of impact. Okay, so my time scale, as I said, is a little bit longer than Ben's. I got here in 1986. The lake level was really high. For those that were around in that era, we had the pumps going in, and then the pumps were only used for a year or two. My research was more related to global kind of problems, El Nino and all that kind of stuff. But in the late 90s, it really became important to get more data around the lake. So we started putting stations out there. And my life is sort of tied into field campaigns, studies, and the lake stations have gone in and they've been there ever since. And that's really important. It gives us sort of a long-term record with gaps during that entire period. But the first really big field campaign that we had was one led by Jim Steenberg in a department called the Intermountain Precipitation Experiment. And it was to look at our snowfall in the mountains and the impact of lake effect snowstorms. So much of the research came from that. And that was a federally funded kind of campaign. And then the Olympics, and that was a big deal. Public safety for the Olympics was a big deal, and knowing what the conditions were upstream of the lake. So as the lakes dropped, though, things kind of changed where we really started worrying about air quality. So wintertime air quality, summertime air quality, and then more recently, this Division of Water Resources tied into this. We started a pilot study, as I'll talk about, on evaporation. And then full circle, we're back now to a state-funded Division of Water Resources campaign on orographic precipitation with many of the same kind of goals in some respects as IPEX. Now, I really like Ben's picture with that extra dot, because my dot's going to end here at some point. And so I like that dot to be thinking about 2034 where the water level is back up here somewhere, but that's out of my control. All right, so what have we done? Well, we have a network of stations around the lake. These are the black dots. And then the red dots are ones where we are helping with sort of communication around the lake. And so that includes stations from the Utah Geological Survey and other agencies and commercial firms around the area. So I'm specifically talking about these stations that were put out starting in the late 90s and then have continued since. So Locomotive Springs is the one that I was talking about, and then I'll talk about Gunnison and Hat a little bit more here. So this is also something that what we realized from the beginning was that there's a lot of agencies, all the state agencies, just about every possible one you can imagine has weather stations, UDOT, DAQ, UGS, a bunch of others. Salt Lake County is a major contributor in terms of its precipitation gauge. So that was MesoWest. How do you take all this data and be able to merge it together into one resource? So I don't have Ben's interactive thing, but I'm cautiously going to ask, how many people have been on MesoWest and looked at data? So thank you. So one thing is, MesoWest likely is going to be going away unless some long-term funding is found in order to be able to take it out, to continue it. So there's about 1,300 environmental stations in Utah that are available. And I do have to say that one of the things that will continue sort of the legacy of MesoWest is something that was spun off from the university, and that's called synoptic data. And for the university, I have to say, I'm a shareholder and on its board, but I'm not involved in its day-to-day operations. But if you're a MesoWest user, I really encourage you to start looking at the synoptic viewer as well. Okay, so back to some pretty pictures. So Gunnison back in 2001, what a gorgeous place. And to be able to have DNR take us out on for us was the 3-hour cruise and hoping that the DNR boat would come back, and they did. Sometimes they looked at us with, like, why are you so, covered in salt? Because we went and dove in the water. So that's the way I look back there. And now the water, of course, is receded. And the pelicans that used to nest at Gunnison have pretty much found that now as a peninsula, it's not really safe for them. And so Hat is another one that you can see the DNR boat, how we used to be able to get to the island, and here's the station. And Gunnison's really gorgeous. I'm sorry, Hat is not. It's about all you bird people, it's seagulls nesting. And so they're kind of messy, so you can get sort of a sense of that. But that's the way Hat looks now, all right? And, the good news was, the pelicans kind of figured out last year that, that Hat might be a place. So I think that's an upscale for the bird population that they like Hat now too. Now, part of the purpose of all those stations that we have is really for the Weather Service, for state agencies and others to be able to manage the lake and be aware of hazardous conditions. And so this is just a count of the number of times that we've seen really strong winds. And in comparison, at the airport, there's only been like 100 hours of this, and instead it's close to 3,000 hours that have had really hazardous conditions. And many of those, some of you that use the vessels out there have experienced this. The other thing is, as you look at air temperature, we've really seen a spike on the land surfaces around the lake, that the temperatures are much higher than what they have been. But I won't take the time to show it. The lake temperatures don't show that as much. And so that's kind of an indication of the moderating effect of the lake itself in terms of the heat capacity of the lake, et cetera. And so I mentioned, and this, it gets a little difficult to just rely on a single station, but if you just compare at the airport from the 50s up to the present time, if you look at the recent time, this is kind of the mean precipitation at the airport. you can see that the mean averaged over several years hasn't dropped. I mean, a lot. It's dropped some. There's no question we've been in a drought. But it's really the fewer number of blues above the mean compared to the number of below the means. So just the characteristics of the precipitation has changed in the region. But more importantly, our precipitation gauges that are out on these island sites are not very useful because they're unheated tipping buckets, and so they don't pick up the winter snow well. And so we have to rely on other ways, and one way is in terms of more radar analysis. And so you can see the Wasatch, the higher precipitation. This is the water year, 2025. And last year it was pretty dry. The airport was order 11 inches. But the average, if you take the average over inside of where the lake is right now, is below that. All right. But I really want to draw your attention to what seem to be these little things extruding into the lake. These are individual storms. This is why, for hydrologic modeling and other things, using long-term averages on these kind of things can be a little less, you have to take in the fine scale precipitation structure of some of these things, because that's what actually contributes the bulk of the additional water in these areas. Okay, so now shifting to evaporation, I'll go a little bit more quickly through this. So if we just go, and this is the picture as of 2017, but you've seen these kind of numbers before, I think, in this forum. If we look compared to the high water mark, the lake itself is down more than 50%. Well, it's now less than 50%. The wetlands, the playa is increasingly a large part of the area, and then the mineral ponds as well. So the state Division of Water Resources, as part of this preparing the integrated plan, wanted to have a study of how are we really going to measure evaporation around the lake. And it involved contributions at this red dot, again, here where we provide some communication support, but that's through the Utah Geological Survey, and they have a station in the wetlands there looking at the impact of Phragmites. But we were tasked to put equipment in the mineral site where we had some prior instrumentation. And then also, if you were here yesterday for Kevin's talk, I'm sure he was talking about what we call the playa site, where we also added instrumentation. So we've been collecting evaporation. This is the first time there's really been any detailed evaporation measurements at high resolution over the last year. And what the real focus is not to measure the evaporation as much as to figure out what kind of instrumentation can you use to be able to do these kind of studies, so that it would provide input for the state planning as they build out additional resources. So the two sites, one is in between two mineral ponds at Compass Minerals, and so there's these are the sensors. They're in the short version here. And a lot of what we were after was, to what extent could we might be able to use less expensive equipment than sort of the full freight in order to be able to measure the turbulence that gives us the evaporation. And then this is Kevin's site, Kevin's tower, and then we added another tower near there to take advantage so we could do the whole energy balance out on the playa surface. So the net effect, if we look in the warm season, which is when most of the evaporation happens, so if we go from April to the end of September at Compass Minerals, then the black line here are just a couple of estimates of how much evaporation happened. And so we have a semi-permanent water source with highly halite filled ponds on either side of it, but varying over time. And it's not too surprising to see that they're very effective at evaporating precipitation. Now, the amount of of precipitation there was quite low over this period, just a few inches. So, not too surprising. Now, part of what we're after is, well, can we improve our understanding of evaporation by using satellite estimates? And so this is one particular source through what's a consortium of satellite remote sensing community called OpenET. And it looks pretty good in the sense that it's getting the right ballpark kind of number if you average over a whole bunch of different simulations of the evaporation. But the range, the uncertainty in it is very high. How do you trust? Which one of these do you really able to understand? And so then if we look at the playa, so if we move to a place in the summer, the surface temperature of the playa, if there hasn't been rain for a while, the surface temperature is 45 degrees Celsius. It doesn't evaporate a whole lot. But when it rains, as soon as it rains, it's a water source, and then it quickly evaporates over time. And we've looked at the same kind of thing on the Bonneville Salt Flats. And you have these episodic kind of events that are very difficult for models to be able to incorporate that kind of detail. But so you can see here that, obviously there's much less evaporation, and there's also not a heck of a lot of rainfall. And, here's where the satellite is underestimating that total. And these are all pretty, preliminary kind of results. And then this is the range, and it's also still very large. So there's still a lot of uncertainty in these things. Okay, to try to summarize and leave time for questions, so the main thing is, and these kind of things really require being able to sample information at high temporal and spatial resolution. And in order to accomplish that, you need, both in situ observations as well as then models and satellite estimates. So how do we go about making sure that happens is, well, we really need year-round precipitation, knowing how much is actually falling on the lake so that you can calibrate that. So we've been testing sensors that would give us better estimates of wintertime precipitation that don't have the problem. I mean, we can only go out to Hat and Gunnison once a year, so if it gets clogged up with a little bit of dirt, then we go, well, we don't know if it's really zero or whether it just is not. So there are ways to be able to do that using the existing stations and or augmenting that. Reducing these uncertainties related to evaporation, again, putting out the really expensive eddy covariance stations requires a lot of maintenance. You have to have people go out there and clean off little windows on the sensors. That's pretty hard out in the middle of the lake to be able to do. Now, the other thing that's going on is the USGS has a buoy out on the lake, which is very helpful to be able to see what the lake temperature is like. So buoy type measurements are one way to be able to deal with this. All of this really results from, if you have these kind of observations, then you can sort of ground truth what we get from our atmospheric models, help that be input to the hydrologic models that many people are dealing with in order to be able to have some confidence in what's going on. And so then obviously the real critical thing is to recognize how diverse the uses of environmental information are on the lake. It's public safety kind of things, the air quality, the dust, all of these things, the commercial applications, and really understanding our water resources. So with that, I'll throw this back up and just, every field campaign has to have a cute logo. Making logos is much easier now because you just ask ChatGPT. And, when I tried with an airplane, it came up with a 1950 bomber looking thing. But, if you play with it a little bit, it'll do a decent job. So with that, I'll see if there are any questions.
Thanks, John. That's a great presentation.
Yeah,
So what's going to happen to this great network and long-term monitoring that you have around the lake once you retire. Is there ongoing support from anybody
Oh,
or?
boy, talk about, throwing out the leading question there, which is, yeah, I mean, I think it really does require more effort on the part of the state, to be able to take on these kind of resources. My attitude is, relying on a university to sustain something for the next 25 years, like I have through research funding, is not a tenable kind of way. These are critical issues related to the Great Salt Lake, and it's something that state and possibly also from some of the things that Ben was talking about as far as the organizations that are trying to support these things. That's going to be really necessary. So I would say, and on January 1, we'll be putting up a little thing on MesoWest that says, hey, there's potential that this is going to disappear, at the end of 2026. So to kind of alert people, and the same thing for the stations. So, other questions?
I was wondering if you have any preliminary results from comparing the LICOR to the other instrument?
Well, yes, and so they all have strengths and weaknesses, and so if it's kind of the story of the three bears. We would really like to now, the inexpensive one is useful as a way if you can tether it with other sensors to be able to sort of have some bias correction. The really expensive one is difficult to sustain because of the costs of maintenance and just not really being appropriate in really harsh environments long term. I mean, dust, just raining a little bit and then having a dust storm is enough to cause lots of issues. So there's an in-between solution, which is we haven't tried, and I think that one needs to be kind of looked at to be able to to see if it might be a way to. I mean, it still will suffer in some of the same kind of ways, but it also is not as. And then there's also remote sensing options using scintillometers, which is a way to do it over a longer optical path length. That's expensive, and then that also requires a fair amount of maintenance. So the location of where you can do that. The toughest part is to get measurements out in the middle of the lake, and it's just really not practical to build a tower kind of thing in the middle of the lake, at least with the current technology.